presentation. Okay, so just a little background. I'm here to share a little story about it, like an industry perspective, another industry perspective on how Dow is looking to transform to or at least aiming to transform to a cloud hybrid on-premise environment. Obviously, HPC is critical, and I like to think of it as a computational laboratory. It's not much different than a lab in some lab building. It's accessible globally, so that's a bonus. But the equipment inside, I think, is real similar to the HPC approach. You got lab instruments, you got software. I like to think of it that approach. So that's my angle. Just a little bit about myself. I've been at Dow for 11 years, high performance computing team. Bachelor's degree in applied mathematics. I've got 3 kids at home. One's a week old, so I barely made the talk. Yeah, thank you. He's good. Everyone's healthy at home. Everything's good. Last name's interesting that I'm in Dearborn today because everyone always asks me like the car. So I really wanted to name our son Ford, but wife didn't go for it.
What's his name?
His name's Colin. Yeah. Whatever works. Anyway, so some of my history with HPC. I started out just a Linux administrator. No HPC background. Learned HPC from the ground up. So we used to have canned cluster environments. Canned, I mean like a Supermicro vendor builds their own stack, gives you everything. At some point, I discovered the ROCs distribution. We've had several implementations of ROCs. So I went from knowing nothing about HPC to doing everything. So today, I'm doing some of the architect work as well, and design. I have on here a self-proclaimed ex-cloud critic, which I think is a really good follow-up to the last cloud discussion. So one of the challenges I've found over the years talking about the cloud is 100% lift and shift is a really hard sell. So I'm glad the talk of the focus of this talk is not 100% lift and shift. We're talking about a hybrid cloud environment, which I think has some interesting approaches, interesting points we could talk about. Okay, so just a little bit about Dow, really similar to the last talk. We've got a high utilization. 85% or so utilization justifies our future growth. If you don't eat your meat, you can't get your pudding. General purpose cluster, I think it's important to mention this is a general purpose. We don't build it for one specific application. It's got to run our CFD, it's got to run our molecular dynamics, computational chemistry, it's got to run everything. So it's got to be really good at everything, but it's probably not built specifically for any of these areas. We got the InfiniBand for the CFD work, the high memory bandwidth for all the computational chemistry, et cetera. Everything works, but it's not custom tailored for any of these environments. We've got some deep learning, machine learning going on with our NVIDIA servers. We've got a DGX-1 recently, so that's kind of a fun little addition to our environment. A lot of high-end HPC desktops, things like that. So that's kind of the broad range of another point to the high utilization rate. So our utilization justifies future growth. We use that every year to promote the next year's growth. At one point, we tried pitching larger clusters, but without the utilization, it's fiscally irresponsible to do something like that. So that's our growth year over year is usually based on the previous year and maybe some sort of projection we see to the next year, but not usually much larger than what we have on the ground as it is. So here's the secret of the presentation. So we are looking to develop processes and leverage a high-performance computing on-premise / cloud environment by next year. We'll get into the whole slide deck will describe exactly where we're headed and some of the key learnings. So we did a proof of concept with Rescale and Microsoft. Rescale's got a talk shortly so that you can learn more about them. Some of the important steps that we have to go through, probably unique to industry, we have to develop a security model, which is a challenge in itself. Actually, I have more details on those in the next slide, so I'll just glaze over them. But cost recovery model, much different than we have today. Today we might throw a bunch of capital at it, but the cloud's a lot different, so it might be expense dollars, and there's certain appeal to either one year over year. Sometimes they like to spend capital, sometimes they don't. Azure integration, obviously important. We need the most secure environment we can. We want to use single sign-on. We want to use all the tools that our corporate IT is happy with. ISV licensing model, we have to understand what solvers we're going to use in the cloud, if their licenses are going to marry up with what we're using on premise. We actually have one solver that absolutely refuses to let us run in the cloud, so that's a problem. But there's all kinds of these challenges. One data point I have on that is Rescale is working to, one of the interesting points for Rescale is a vendor, they're working to work with the ISVs to come up with a special pay-as-you-go, which would be interesting for certain cases, or bring your own license, things like that. And obviously data transfer down to Azure. I don't know if anyone's familiar with Azure. There's the whole concept of the express route, which is your dedicated network between yourself and the cloud environment, or your company and the cloud environment, which Dow does maintain. Obviously, we need to train our users at some point, and hopefully sometime next year we'll have a working on-premise cloud hybrid. Okay, so my crazy heat map. So this is the marriage of CPUs or CPU hours from just a couple to several thousands to 100,000s, and the urgency of the job. So what this is trying to describe is all of the full range of computing that we could do at Dow and how it might look today. So small jobs, maybe a small CFD job, small computational chemistry could easily land on the few CPU range on the enterprise workstation. That's what we call our laptops. Just beyond that, the high-end desktop, you start to get into the high-end desktop range where you've got a couple more CPUs. Urgency, any amount of urgency can be fulfilled on those because they're small. You can start it right away and come back to your computer. Where it starts to get interesting is our cluster space, so the blue space. We can easily run in the hundreds to even close to the thousands of CPU range at any time with high urgency without much work. So we might have to juggle some jobs around or make some special cases, and then in an hour or two they've got a space to run. But where it starts to get challenging is when we're getting the thousands to tens or hundreds or millions of CPU hours. That work, let me see if I got the right button here. So the computational chemistry work today is one of our highest workloads. That's forced into this quadrant because we can't do high urgency, time-sensitive work because we might have a good sized cluster, but being that it's general purpose, everyone's got their own story as to why they should have the time. And putting two engineers against each other doesn't ever go very well. So we're forced into this category today. So we can do the millions to 5 to 10 million per user in a year, but it's stretched out over the whole year. So there's no sense of urgency. The business just has to wait. That's the only choice, that the Dow business has to wait. So where we're looking to head, that didn't look right. There we go. So this green quadrant up here is our opportunity statement for cloud bursting. So where we'd like to provide the hybrid is to satisfy this green spot. Say that if we could run our computational chemistry, if the business deems it necessary, with time sensitivity, we could leverage the cloud to do some high burst scenario and satisfy that workload in a short amount of time, which we just don't have the option today. It's unexplored. It's just the way it is. And obviously a couple other extreme use cases like massive GPU farms and such, which we don't have on premise. That's another interesting point for the cloud in the green space. But So just another point on that, what does that mean for Dow that we can't, obviously time to delivery on projects is important. That's the biggest sacrifice that you've got. But I also believe that it's a creativity barrier. If you can't build a sandbox, if you can't build a massive sandbox in a small, or a sandcastle in a small sandbox. So this is our big sandbox for the engineers and chemists to play in. If it's just not a possibility, no one's going to try. Or it's certainly more of a barrier. It's not that they won't try, but it's more of a barrier. So sorry there's no numbers on here, but keeping data private, obviously our capacity and growth follow each other. So my point here is that, so we've grown from here to here, and these are exact values, just no numbers here, but our capacity, our utilization is always right where we want it to be. It's 85%ish, gives us a little room for a little extra burst. The problem with that is you can't capture and measure the actual demand. So what if we had a lot more? What would people do with it? What would we be able to do with more hardware, such as the bursting capability? Yep. So some of the challenges in more detail. This is part of our roadmap on slide 2. But data security obviously is right on the top. Our data security is of utmost importance. Let's look at a Fluent model. It's a sensitive proprietary design of an impeller. You don't want to send that out. It might not be crown jewel data, but it's highly sensitive, and these are the things that we have to protect. Computational chemistry data might be a little different. It might be a needle in a haystack problem. We send thousands of simulations up in the cloud. One of them might have the golden ticket, but they're all sensitive. So that's our biggest hurdle, is to get upper management comfortable with cloud security and the encryption methods and all the stuff in between. What do we have to do to get there? Sure, Dow's doing some cloud computing now, but we're not sending those kind of data sets. These are foundational data from R&D. These create the next product that Dow might work on. Cost recovery model, I mentioned that before, but who pays for what? Today, our group pays for everything with capital. Sometimes we'll get some influx of funds from another part of the company, but how's that look going forward? Does the business pay for this? There's all kinds of questions around this expense versus capitalization model with the cloud, and that's going to be questions we need to answer. AD, Active Directory is I don't want to make it sound easy, but with the whole Microsoft Azure Enterprise Agreement, you can tie into your enterprise agreement through your rescale third party, and you've got your integration. So there's some simplification there that we've seen already. We feel pretty good about it, but there's still a road to be traveled. ISV licensing, we already talked about that one. We need to see. It's the unexpected ones that you might find out. You need to do some cloud computing, and you might not have already gone through the exercise with your ISV, so we need to get a good handle on all these potential cloud bursting scenarios and run these through the paces. And data transfer, I mentioned express route before. So if Dow trusts the Azure connection, Azure trusts the Dow connection. Dow doesn't exactly trust the Azure connection. So that's a challenge, back to the ISV, that's a challenge for talking from Azure to your on-premise license server. So you could do a DMZ license server perhaps, or a cloud-based license server, but either way, that's just the challenges that we're faced with. So, This is our POC. I'll walk you through what we did with Rescale and Microsoft. We two important use cases here. One is the computational chemistry POC on the left. So what we did is one of our chemists created an input deck of 1,400-ish computational chemistry molecules. I think he mentioned they were on the order of under 50 atoms per molecule. And so they ran in a fair amount of time. Our exercise here wasn't to benchmark speed, it wasn't to benchmark efficiency, it was really to say, can we burst to something massive, more massive than we could get done in a reasonable amount of time on premise. And so that was our main objective. Our second objective was to, which isn't really described here, is can we run a day-to-day simulation in the cloud, similar to a small simulation we would do on premise. And those aren't mentioned because they were pretty trivial, but just the big cases are mentioned here. So for the computational chemistry job, each one was run on a 7 CPU Azure instance, H16R instance. And at one point, we had spun up close to 10,000 cores. It took roughly just under 30 minutes, I believe, to stand the whole thing up. So comparatively, think about, at the time, I think we had 500 CPUs not busy on premise. Everything else was running. We would have, I can't remember, I did the math in my head a while back. It was 13 or 14 times faster to do this in the cloud. Did the whole thing in 5 hours. All the calculations were finished in 5 hours. Goal was met. Cluster was shut down. Everything's finished. Charges stopped. You know, everything was turnkey. And the work was performed by Dr. Peter Margel. Let's mention his name there. So that was one case. The second case was our CFD case. We scaled up 20 to 200 to 2,000 CPUs, which the input deck in this case didn't really justify 2,000 CPUs, but again, it was just a can we do this? And we did. I can't recall the actual limit on the Azure instances for, it was an InfiniBand limitation, but we did not reach any limitation on InfiniBand, so we started the whole thing up, one InfiniBand fabric, I think it was FDR. The whole thing was running in a very short amount of time. I don't think I have it on here, but I feel like it was just a couple minutes. Cluster was set up in a couple minutes, job was verified. We didn't run it through its paces because it wasn't really necessary. We weren't benchmarking speed in this case, we were just benchmarking feasibility. And the goal was met in 15 minutes. So to carve that amount of resource out on a cluster that typically has only a small number available would have been a couple, at minimum, a half-day effort to try and figure out, you know, where we're going to take the sacrifice from and how to justify that. Because, like I mentioned, it's with a general-purpose cluster, and everyone has their own story for why they need the CPUs. It's hard to make that case day to day. The story changes day to day. Another point here is that, so looking at the 9800 CPU cluster that we stood up, that in retail costs, just based on some rough number I'm pulling out of nowhere, roughly, I don't know, 8 to 10 million bucks, something like that. Yeah, I think our street cost on those hours was something like $2,500. So it's an extreme case. But that's the case that we're after, is that green quadrant. You know, what's our burst case for the times when we really need it but can't do it? That's I think that's an interesting approach, and it's much different than the lift and shift 100% of your environment to the cloud. That's a losing. I think it's easy to crush those dreams. If you try to replace the entire thing in the cloud, it's easy to see that can be cost ineffective, but something like this is certainly more appealing, I believe. And one more point, this is, so just based on the speed up and knowing how much capacity we have internally, something like this could take a 1-year simulation down to a week or even better. And we'll get into this last slide to kind of follow that thought up. We do not do any business with this company. I just want to throw this out there. They are talking shortly, but 10,000 cores is not a lot to most of the people in this room. And it's, I mean, it's a significant amount of hardware, but just to throw this other approach out, Univer recently published this article where they deployed 1 million CPUs in AWS, and the whole thing was ready in 2.5 hours. So just a thought there that, yeah, 10,000 isn't a big deal, but 1 million certainly is. So if this sets some comfort with me. This actually came out like a week after we did our POC. And so our realistic burst case at Dow, I don't know what it would be, but let's say we wanted to use 50,000. It's well within range. This just shows us where we're able to go in the future. And thank you for listening. That's my last slide. Thank you. Anyone got a mic?
I have just one observation, is that I'm very happy that you moved to the cloud. We started HPC 20 years ago in Repsol. Repsol is an oil and gas company. So we have been following the cloud, and we have realized that now is the time. We have moved 11 petaflops to the cloud. We haven't moved to clusters. So I can tell you that jobs that we were doing in 1 year, now we are doing in under 5 minutes, for instance.
You said 5 minutes?
Eh?
Did you say 5 minutes?
5 minutes, yes,
Okay.
under 5 minutes.
Right.
It's a combination of hardware and the algorithm and everything. We have not published this thing. We think we are going to publish maybe in a couple of months, but this is what we get. And the other thing is that I don't really understand when people is talking about moving to the cloud based on cost efficiency, because this is not the reason. So the only way you want to move to the cloud is not to be cheaper, but is to be more effective, not more effective, but to make more business. So in our business, for instance, in oil and gas business, the NPV of the projects is huge impact. So you can accelerate the business cycle 50%. That means from the time you capture an area on acreage to your first oil, this is billions. It's not, you are not saving hundreds or millions of dollars. You are making deltas of billions. This is what you really need to, I mean, if you have supercomputing, is because you are going to accelerate significantly your business cycle. That, as we do. In Brazil, we have made $7 billion. The other thing is, for instance, now thanks to the cloud, instead of having facilities only in Houston for our people, now everybody in the company in 64 countries, they can access high-performance computing. So it's just for consideration about the good things of the cloud. And the other thing is something that I saw is the third-party licensing. Something that maybe is a problem for the cloud is if you don't have a proprietary software. Because if your hard software is not proprietary, there are no business models with third-party vendors in how they are going to charge the software when you deploy in the cloud, because it will be extremely expensive for you, because these models don't exist.
That's a good point. There's two things I didn't get to talk about, or I didn't touch on. Two other use cases for the cloud, which are similar to what you just mentioned, is a disaster recovery model. We don't have one with a single on-premise resource, but with a second resource like a cloud computing environment, we do. And again, our capital cycle, and I'm sure this is true for a lot of industry, capital cycle starts, I don't know, September, October, and you don't get your stuff until middle of next year. But HPC moves a lot faster than that. So we need an opportunity to test these things and spin up some amount of resources in that time frame. That's an opportunity.
Thanks for your presentation. You mentioned developing a cost recovery model, and I'm curious to know if you have one today for your on-premises system, and maybe you could describe that. And even going forward to the cloud or adding the cloud into the mix, would you plan on adding that onto your on-premises capability, just to sort of help people make the decisions about, speed versus low cost?
I can't fully answer it. I don't know. I don't know how it's going to look. I think we have some ideas, but so Dow spends a lot of money with Microsoft, so there's certain parts we can leverage from that agreement, but we don't know how the recharge is going to look yet. We don't know. There's probably 10 different ways to do it, but we don't know what it's going to look like. We capitalize everything today. Everything's capitalized. No leasing of equipment or anything like that. So so that's the second part of the challenge, is who pays for it, and is it an expense model now? Because that changes the game a lot. Sometimes the company is really good about spending expense dollars, but just depending on how things look, I don't know how that decision's made. But
so, Mark, just giving some thoughts to the question you're asking, since we have both cloud and on-prem at GE, I'd actually caution against using the same pricing model for both. And the reason is for what Francisco outlined and what's been said elsewhere. The value proposition for moving to cloud is about immediacy to answer, consumability, and so you price that way. For your on-prem environment, you're making long-term capital allocation investments, and you don't want to have to price in the risk of volatility. So the moment I move to a cloud-like pricing model internally, I have to price risk of underutilization and a bunch of other factors in, and suddenly my price points get pretty squirrely. And by the way, I get the behavior I don't want, because now I'd get into attempting to episodically augment my capacity based on surges in capacity, and now I've just got two products that are competing each other both in their strong and in their weak points, rather than well-stratified services based on the use types. That's our experience, at least.
Any more questions?
Could you go into the ISV application support? We've ran into that significantly in like 40 ISV applications. I think 2 of them allowed us to run outside of our physical premise, and some of them were even tied to where the engineer sat. So if someone was on sabbatical or working at a telecommuter, they actually weren't allowed to use the software. So I was wondering how you've approached that. And I mean, I don't even know why they care half the time unless it's export controlled. Yeah,
so that's a problem. You might already have 10 different agreements in place that are locked in from many years ago. So you might have one engineer that's named or something like that. And that's definitely a challenge. Without throwing any vendors' names out there, so Rescale, for example, they're already working with a couple of these vendors, and vendors are, as far as I'm told, are adopting this philosophy for the cloud. Not all of them, because we have some that just absolutely refuse to let us use the cloud, no matter what the use case is, no matter who the person is. So that's a problem too. But yeah, it's definitely a big challenge. Do you buy a new? But I think it's an easy challenge if the license is set up right. Let's say it's just a usage license or a named user where the amount of CPU hours aren't counted, and you're talking about a massive scale up where that really minimizes the license cost, because if it's not a scaled license, if it's not based on CPU hours, that's kind of one way to look at it, because we're not talking about throwing everything at the cloud. At least in this case, we're just talking about the burst scenarios where the licensing costs might be minimized by that. But yeah, we have the same challenges, and we haven't done a full review of everything, because at this point we don't fully understand which softwares are even going to be used in this environment. We have an idea, but I think it's the sandbox thing. Build the sandbox and let them play. Nobody's able to play in that space right now, so a lot of these things are unanswered, I believe.
Okay, any other questions? William, thank you.
Thank you.